Hello everyone, I'm Dora. Today I'm going to talk about various applications of calculus. I will talk about my part from three aspects. First one is applications of derivatives in economics. In economics, derivatives are used to model how various economic quantities change with respect to other variables. Here are some key applications. The first one is a cost function. It represents the total cost of producing a certain quantity of goods or services. It's often denoted as Cx, where x is the quantity of output. Marginal cost is a derivative of the cost function. It represents the additional cost for producing one more unit of output. Number two is average cost function. The average cost function is the total cost divided by the number of units produced. And we can see formula here. The derivative of the average cost function helps to determine how average costs change with changes in output. And it's often used to find the optimal production level where average costs are minimized. Number three is revenue functions. The revenue function is the total income a firm receives from selling a certain quantity of goods. Here is a formula where Px is the price per unit at quantity X. Next is average revenue functions. It's the total revenue divided by the number of units sold. Here is a formula. This is often equal to the price per unit Px if the firm is in perfect computation. The next one is profit functions. Profit function is the difference between total revenue and total cost. It represents the profit obtained by selling X units, and here is the formula. We can see it from here. The last one is average profit function. It's the total profit divided by the number of units produced. This is useful for understanding profitability on a per unit basis. Now I will show you some examples. We suppose that the total cost function is Cx equals to 100 plus 5x plus 0.02x squared, quantity of goods or services. We can know marginal cost here is a derivative of the cost function, represents the additional cost for producing one more unit of output. We first find the marginal cost, and then we can know that at x equals 50, marginal cost is 7. So the cost of producing one additional unit at x equals 50 is 7. Here are other examples. They are similar to the first one. Now I will talk about part 2. Part 2 is washer method. The washer method is a technique used to find the volume of a solid formed by rotating a region around an axis. It's used when there is a hole in the middle of the solid, creating a washer shape. The method is to cut the rotating body into countless thin sheets similar to the shape of a washing machine, and the thickness of each thin sheet is very small. Then calculate the volume of each thin sheet and add up the volume of all thin sheets to obtain the total volume of the rotating body. The middle part is the formula, and Rx is the outer radius, and Rx is the inner radius. Here is the example. According to it, we can know that outer radius Rx equals root number x. Inner radius Rx equals x squared. So we can calculate according to the formula now. The last part is moments and center of mass. The moment of a mass distribution is a measure of the distribution's tendency to rotate about a specific point or axis. Center of mass is a point where the total moment is balanced. Here we can see an example of part 3. Find the center of mass of a uniform rod of length L equals 2 and mass density Px equals x, linearly increasing. First, we can calculate the total mass of moment about x and center of mass according to the formula. That the center of mass is at x equals 3 quarters. That's all for my part. Thank you.